When you subscribe to a pro-tier AI platform, you are buying into a specific expectation. These multimodal ecosystems are marketed as robust engines, built specifically to handle heavy, professional creator workflows without breaking a sweat. On June 7, 2026, a user put that promise to the test with a complex multimodal request. The goal was to generate a 25-second vertical documentary, relying on a dense 135-megabyte reference video. The text prompt provided strict historical parameters. It included exact timestamps and requested specific visual cues, specifically a World War I battlefield featuring soldiers advancing through deep, muddy trenches. The backend accepted the payload without any friction. It parsed the data and displayed the standard confirmation: "I'm generating your video." A smooth initial intake establishes trust. It tells the user that the file formats are correct, the parameters are understood, and their paid account resources are now actively working toward delivering a final asset. But after several minutes of heavy processing, the generation loop abruptly stopped. The process was terminated by a sudden system exception. The backend threw a specific error message. It stated clearly, "Video editing isn't available in your region yet." Immediately after this crash, the user interface degraded entirely. The standard attachment tools vanished, completely blocking the user's ability to upload images or reference files into the chat window. Hitting a regional compliance block midstream points to a deep configuration flaw. Legal and geographic restrictions are supposed to trigger before any processing begins. Crashing after several minutes of compute time means the backend itself failed. In software architecture, there is a standard security step called a pre-flight check. This is a quick diagnostic where a system verifies permissions and resource availability before it spends any actual computing energy. This diagram shows how a properly functioning compliance blocker works. If a user is in a restricted region, their request hits a wall at the pre-flight stage. It is rejected immediately, costing the system zero processing time. The user restructured the prompt and submitted a second attempt. It resulted in the exact same hard crash, proving this was a persistent systemic wall, not a temporary session glitch. The technical contradiction here is location history. This exact account had successfully generated manipulated video assets from the very same geographic location in Poland earlier that exact day. The regional restriction was applied retroactively. The system allowed the operation to proceed, failed internally due to a severe routing error, and then threw a compliance block to justify the hard crash. After the interface locked up, the user opened their account settings to check the usage metrics. This panel shows a catastrophic quota depletion: 76% daily, 70% weekly. The timestamp confirms this massive drain happened during the crash. The platform billed the user for compute time spent on its internal error, not a delivered video. This creates a severe penalty for the user. They are effectively financing the platform's internal software bugs with their own premium credits, leaving them locked out of their paid capacity for the remainder of the billing cycle. The user immediately escalated the issue to the Google One support channel, providing a fully documented technical complaint detailing the broken routing loop and the unfairly depleted quota. The initial response from Tier 1 support was promising. They confirmed they had escalated the matter to higher-level engineering specialists for review. The user then had to wait for hours. Their daily professional workflow was completely stalled, and their paid account remained frozen with absolutely no way to proceed. Hours later, the final corporate response arrived. It was a boilerplate refusal. The support team acknowledged the situation was not ideal, but explicitly stated they were unable to change their current process, offering no refund or reset for the stolen quota. Rigid, unyielding support structures amplify technical failures. By refusing to recognize the backend bug and restore the wrongfully deducted credits, the support team permanently trapped the user in a failed operational loop. To protect their production schedule and bypass a platform lock, the user had to immediately pivot. They took the identical multimodal request to a competitor. The identical source files, timestamps, and historical parameters were routed directly into OpenAI's ChatGPT. The external ecosystem accepted the task seamlessly. It compiled the vertical video clip without throwing a single geographic error or crashing the user interface. Because the external model delivered the asset without sound, the user deployed local terminal automation to cleanly merge the resulting video with a period-accurate soundtrack. This flawless execution externally proves that the original prompt was perfectly valid. The initial breakdown was entirely an isolated failure of Gemini's architecture. Let's look at the timeline. A pre-flight architectural failure caused a systemic crash. That crash resulted in a massive billing penalty, and human support rigidly defended the broken process. Compare the immense friction of that original platform with the frictionless output provided by the competitor. One system stalled and charged for the failure. The other simply did the work. The greatest threat to a major AI platform is not that its models will occasionally generate a bad image or hallucinate a fact. The real danger is infrastructure lock. This happens when a platform's backend processing and its internal billing systems become tightly intertwined, meaning users are actively penalized for the platform's own operational failures. In a fiercely competitive market, professional creators will not waste time fighting broken support loops, and they certainly will not pay for failed compute time. They will simply abandon the ecosystem entirely, taking their workflows to a platform that actually works.